Welcome to my channel. In this video we will learn how to navigate using VOR stations. What VOR stations are, how they work, let's see in this tutorial. In the next tutorial we will start the world of navigation using global positioning systems, GPS. But VORs are still very important and very interesting, and they are very tricky sometimes to even pilots to learn how to use them. In this video I will try to show you a easy way to understand how VOR stations work, and I think this should help you become a great pilot. Let's get started. As you can see on the map, I have enabled in little nav map to show me the various VOR stations. So let's take one of them and zoom. So as you can see, we are in, if I show the airports in here, we are in Auckland International Airport. We are on runway 30. And there is, in fact, as you can see, this shape in here. It is, if I click on it, little nav map will give me information about it. So it's called VORDME. VOR is it is just a station with very high frequency, transmitting at, you can see the frequency of the station, which is 116.8 megahertz. And because it's in megahertz, the wavelength is around 2 meters. Which means to be able to connect to that station, we have to have a direct point of sight, which means we have to be flying. So normally it is hard or even difficult to connect to a station when you are on the ground, which in fact you may not need to do that. So how do we connect to a VOR station? And as you can see here, because this is called VOR DME, so it is 2-in-1. VOR will give us a kind of a indication about a certain radial that we can connect to. I'll explain what that is. And the DME can give us a distance to the station. So if, for example, I am flying in this area, I can connect to this VOR DME station. The DME part will give me the distance, so I can know if I'm flying directly to this station. And because I'm connected to this as a VOR station, I can connect to one of those radials and be able to fly and intercept that radial. So, okay, let me explain further. As you can see from this shape, let me take another one, maybe it will be clearer on the map. Okay, let's take this one. Okay. So as you can see, it's represented in this circle, and when the shape is this means it has a DME station also in it. So now we will select another one to show you some differences. As you can see here, it looks like a circle with a 360 degree, and this line here represents the zero angle with the magnetic north. Okay, so there are like lines this way, this way, this way, and across the 360 degree. Now, how do I use it as a VOR station? So assume I am flying in here, okay, here, and I want to fly directly to this station. There is an easy way. So first of all, I tune to this frequency because every VOR station has a certain frequency. If I click on it here, you notice it has, this one is 117.0 megahertz. And if I'm in here and I want to fly directly to it, I can connect to it and look here carefully at the angle. I can use an instrument, okay, inside the aircraft. It's called CDI, which is Course Deviation Indicator. Let me switch to the aircraft and show you the instrument. So as you can see here inside the aircraft, this is a CDI, okay? how does it work? Again, similar to the the direction indicator, but which means it has an internally a gyroscope, but it shows us the deviation from a certain course that I set versus the electromagnetic signal that is coming to me from the station. What does it mean? Yeah, so what it means is, because this one is called CDI, course deviation indicator, okay, it tells us how much deviated we are from a certain course that we set. And once this vertical bar or needle is in the middle, this means we are completely aligned with the course that we set. So the way it works this way: assume I want to navigate directly to the station, okay? Disregards where I am. I return this OBS bar until this becomes straight. And if it is 2, this means I am completely now connected to the station and I want to fly to it. And if I continue to fly by keeping this straight, this means I will fly on the route that will take me directly to the station. When this needle goes to the left, this means I deviated my course to the right. And if this needle goes to the right, this means I have deviated my course to the left. I hope this does not confuse you. It should not, in fact. So to see it in practice, what we will do, I will show you the map one more time, and I'll show you about a scenario that we will fly, and this scenario shall help us see how those VARs really work. And they are really fun. I mean, once you understand how they work, then it will be just a simple geometry to really see how you can navigate using those. So assume we will take off from this Auckland International Airport, and let's tune to one of those VORs in this area in here. Now, if you look here, you notice this VOR has a different shape. This VOR is used by military and civilians as well. And this VOR is only for civilian use. So you can see here, and as well, this is a VOR DME. So let's tune to this one, which is 114.1. All right. And let's, for the simple reason, let's just fly directly to it. So if I come back to the aircraft, what I have done is, okay, I will explain. In this aircraft, like in most aircrafts, there are 2 navigation systems for backup. This navigation system is related to this CDI, and this one is related to this CDI. Now, there is a difference between this one and this one. As you can see, this one has 2 needles. So this can help me navigate vertically, okay, and horizontally. So I can tune, as an example, to an ILS runway, and we will explain in the future what ILS, like instrument landing system. And you remember when we were landing every time, and then we spend efforts to have a proper sliding or gliding slope to the airport. We can have, you know, this CDI to guide us while landing, so that we can follow this horizontal bar to guide us, as you mentioned, and follow it as a gliding slope. So this can give us this. Leave this for a future tutorial. All right, but for now, let's use this now. So if I tune this to 114.1, and just for comparison, I also tuned the second one for 114.1. All right, so now why these are not working, even though they are on? Because the signal, we cannot intercept the signal. Why we cannot intercept the signal? Because we are on the ground. You remember we said we need to climb to a certain altitude so that we can have a point of sight between the aircraft and the VOR station. So let's take off and show you how immediately when I take off, something will happen in here. And then we will tune those VOR. We will use both of them, but they will be similar. We can use any of the 2. So that we can go straight directly to, if I come back in here to show you, so we will go straight to, as we mentioned, to this station, okay, which is in here. All right, So let's begin. We take off first. Release the parking brake and start the throttle very elegantly, because those aircrafts with the single engine, they have the tendency to drift to the left. And now, okay, cool. Look carefully at the CDI indicators. Oh, now we got the signal. So we are climbing gradually. Now, what does what we can see here in front of us tell us? I mean, what do we understand from this? So as you can imagine, what is the name of this instrument? Course deviation indicator. Indicator means like also not 100% accurate. So it's giving us how much we are deviated. We are deviated from what? So if we don't set up a certain course, then this information in here does not make any sense, because we need to look at the destination or the course that we set. So let us set now. So what we will do now, we will rotate this until, you notice here now we've got this arrow. What does it mean? We can tune the station to be, we want to go to the station or we want to leave the station. This one is called to, because we want to go to the station. And we keep rotating, okay, but of course I don't want to keep, turning, because this will, so I keep rotating this until the needle becomes straight. What does it mean when the needle becomes straight? Now let's first get it straight, and then, okay, so now the needle is straight. What does it mean? This means where we are right now. If we draw a line between this, if we fly straight, on which direction? On this direction, which is 120, 130. So if we fly with, you see this, this indicator in here, the heading. If we put a heading of 130 and we fly straight, we will arrive to the VOR station. Interesting. So this is why, let us turn now. And you notice now, because, I mean, if we continue flying, we will deviate also more. But let's turn now and fly to 130. Okay, so 240, 210, 180, 150, 100, enough. Yeah, 130. And let me manage my altitude, because I don't want to climb too much. Okay. Now you can see what is our direction is we are flying around 120. Okay. Now because we are far away, this will not be very much sensitive. And once we become closer, because now you remember when we are very much away from the station, if we slightly deviate left and right, okay, this instrument, you notice here, because it's showing this means we can see the signal and we are connected to the station. We will not use this one here, we will use only this one. And forget, as we mentioned, because we are not getting vertical data, so forget about this. This will stay in the middle. All right, now to show you some sample, if I go right, you expect the needle now to go left or right, and I will go for like this. So I'll fly for like a few seconds this direction. You notice how the needle started to go left. Why? Because we are deviating to the right of the course that we have set, which is 130 degrees in here. Okay, so you see? So wherever we are, okay, so to give you an idea now, let me go big scale. And look where we are as an aircraft. So it does not important our actual attitude. So yeah, we are flying this direction, but we are tuned to which station? To this station, right? Now, because we are still going straight, we are deviating more to the right of the station. If you draw a line, okay, you notice now we are to the right of that line. How can we correct our course? Assume I don't want to change things in here, okay, in the aircraft. So let's go back to the aircraft. Assume I don't want to correct anything now to this. What can I do? I can, of course, move left, and I need to move left because what is my course? 130, right? So if I stay on 130, I will not deviate more, but I will not come back to be on course. So I need to move more to the left. And if I show you this, yeah. So I will turn. Yeah, we deviated a lot. So now we are turning back. So now let's align it back with the station. How do we do that? We need to move to the left, and our line of sight, which is, we call it the radial, is in this case 130. So this to correct it completely, we have to move to the left beyond the angle 130. So now we are on the 130. If we stay like this, we will still deviate it to the left all the way. So we move more to the left. And now we stay this way. So let's fly for like a minute in this direction, and then you will start to see the needle becoming in the center. And we refer to this as we are intercepting that radial. Which radial? The radial 130. So you can imagine now, it's a circle with radials in all directions. I can tune to any radial, fly to it, intercept it, and then follow it. You don't need to practice this. For me, it took me some good amount of time to really understand them, and it's really amazing, especially if you use a concept called triangulation. So what is triangulation? Triangulation is you can tune to two stations at the same time, and because you have a triangle, it's the word triangulation, if you want to learn it, triangulation is used in multiple contexts. And this context, which is the exact word is used as a triangulation, is you tune to two stations, and then you can draw a triangle. Based on where you are on the triangle, you can calculate your exact position in this case. And triangulation as a word is used also in data validation. So you can refer, if you ask two people the same question, and if they give you the same answer or a different answer, the technique you have used to validate the information by having multiple sources is also referred to as triangulation. You notice now we are completely aligned, and if I continue to fly like this now, I will deviate more to which side? I will deviate to the other side, so I need to come back and fly which direction? 130. So VOR are very fun to use, and they are still very much functional, so they are available all over the world, and in the simulation they are all functioning. Yeah. And even when we use the DME part, which is the distance, it will be amazing. But in this aircraft is not equipped to receive the distance information. Okay, so before I close, I will do one more experiment, and I will show you by tuning to another station and try to intercept one of its radials. So look here, we have another VOR stations. And as you can see, this VOR station, what is the frequency? 115.8. Let's first tune to it. Okay, 115.8. So we will use this one. 115.8. And notice now, because we are not tuned to any station that's functioning, we are getting nothing. And once we tune to the right one that we can see signal, okay, 115.8, we connected. And now what does it mean? As we mentioned, the needle like this does not mean anything. Now if we look at the station, okay, so assume, let us do the following. You can see here this station, it has, this is the 0 angle and this is the 90-degree angle. So let's do this. Assume you see this virtual line in here. Let us do something. Assume I want to fly to here and then turn and go to the station. All right. So what do we do in this case? Because I want to intercept this 90-degree line. So what I do, I turn this OBS to 90 degree. Okay. I notice how the needle moved a little bit because we are close to it. And then what I do, okay, I continue flying straight to intercept that radial. And once I intercept the radial, what do I do? Because the needle will be in the middle, I turn completely left, okay, and I need to tune to what in this case? So I will show you now how you fly directly, because I need to do another adjustment to fly directly to the VOR station. You can see now on the map. Why did we tune it 60, not 90? Yeah, this is 60 because we crossed it, in fact. Yeah, so we crossed to the other side. If I turn completely now, I can come back and intercept it one more time. You can see on the map, and I think you can see also the station. So this is how aircrafts used to navigate using instruments. Okay, now I think it's enough. Using instruments before the GPS existed. Come on. Don't tell me so. We are to the left. Every time we are lost, we can keep rotating this until the needle becomes to the middle. And if we fly with a 70, 60, 75, so if we fly 75, we are going away from the station, as you can see. But if I want to fly to the station, I need to keep turning this until it becomes to, not from. So this is the navigator. This is the co-pilot sneezing. Okay, and now let the needle comes to the middle. I think the idea is clear. After I do this example, I will end this video and I will. Okay, so as you can see now, what this CDI told us now, I need to fly 250. So where is 250? Is in here. So I need to change course to 250. And if I fly 250, I will go straight. And look at the map, how the moment I turn 250 degrees, the aircraft will be directly flying to the VOR station. 240, 250. Okay, now we've already deviated slightly to the left. Fine, we can keep this aircraft slightly to the right to intercept. So look carefully at the map now. Okay, we are slightly to the left if you draw the line. So we can just a little bit fly to the right and stay a few seconds to intercept the radial again. And once we intercept the radial, which means the line becomes completely straight, we shift back and we fly which direction? 250. And if we continue to fly precisely 250, and this is why if an aircraft like this, it has a what? A simple autopilot. So what I can do, I will show you this now. I can set the heading to what heading we want? 250. 250. We will have a lot of advanced tutorials on navigation. And then we turn on the autopilot when we turn it to heading mode. And now magic. Why the aircraft is not turning? I need to change this into navigation. So audio navigation. This one works only on this GPS. All right. So as an example, yeah. So it cannot navigate using. No, it should wait. This is heading mode. We said heading. Something wrong in the GPS. Maybe it wants to use this Garmin only. Yeah, I think so. Yeah. So we got the idea now. We have deviated to the right, as you can see on the map. If we turn left, we can intercept again the radial. Okay, we are flying too low. This means teaching pilots is not easy at all, because the pilot instructor needs to focus on flying the aircraft while communicating the training. All right, so thanks for watching, and stay tuned to the next videos, tutorials about various subjects, and we will cover, as you mentioned, global positioning systems, and then flying will be, I can say, also very much fun, because instead of flying manually, we can fly using the instruments and have the autopilot and the GPS to guide the aircrafts. There are a lot of other things to cover, waypoints, highways in the skies, etc., etc. Stay safe, and thanks for watching.